But data science can go beyond just building models or clusters or segments. It can be building an analytical file that can be used for reporting. So for BI. So often enough you will have you'll have needs from the business. They want to produce reports. Could be dashboards. But underneath that, the underpinnings of those dashboard type reports is somebody that's worked the data to create that information that can be used, let's say in Tableau or some kind of data visualization or some type of executive dashboard, right? So data science is not just about building models. It's a lot broader than that. It's basically, it's a knowledge discovery process and arriving at solutions, and that I keep that broad. That could be both for mathematical, advanced type solutions, or even non-mathematical. Basically, a file, a file that can be used basically as a pivot table. Okay. From a business standpoint, this is about really maximizing return on investment. So for myself, being in business for many, many years, this is it's always been about, okay, it's nice that you've done this nice fancy stats stuff, but back when we were first doing this, I mean, businesses are now more accepting of data science because it's been around now, but in the early days, it was very tough to say, oh yeah, I'm using regression, I'm using statistics. People's eyes would just glaze over like that, right? Oh my God! So you had to show why this was a value. So I would not talk very much about the stats, and more about, well, this is what I did, and this is the value. This is the value of what I did versus not doing it. So then and then you apply it, right, to a campaign, and they see the huge value, and then that's what's resonated within the business communities. When you started to apply these techniques, they saw the dollars, they saw the tremendous value, tremendous return on investment.
As you said, it can be interactive. Can I ask you?
Sorry? Yeah.
Yes, I think if to have something might not interact.
Yeah.
So you said, for example, you said campaign.
Yeah.
So on a campaign,
like a marketing campaign.
Yeah, marketing campaign. I get it. I worked in marketing for more than 5 years. So
yeah.
So people like you, what do you think that a marketing campaign is successful? Do you think in the terms of success of today's customers you have got, or do you extrapolate it to the future customers? How do you think?
Well, we build a tool, and then we extrapolate going forward. So we build a solution, and then we take that solution, and then we deploy it, and predict. But we don't predict. What we're trying to do is we don't really predict a point or an essay. This person's likely to respond at 0.02, or they're likely to buy. What we're all about is basically rank ordering. So what should who's my better customer for this type of product, or what product should I promote relative to other products, right? So it's less about the numbers and more about rank ordering. So the value of data science is ranking, is being able to rank records, rank outcomes, and less about the actual, point estimate or score or whatever that we use. It's really about ranking.
Okay.
And that could be ranking customers. It could be, if you're using e-commerce, it could be, it could be saying, okay, this is what we should offer you next, based off a number of products, right? So, anyways, here, this is just some more motherhood. Data science is a growing area, more data, more tools. We have advanced statistics, open source nature. This is probably, without a doubt, the biggest change in data science is just the open source nature. The fact that R, Python, people can put their code right out there on GitHub, right? And SAS 2 has its own open source nature, right? You can go in and they have the SAS support functions where you can get code and all that other stuff. But what's the fundamental essence of data science? Again, it's to me, it's about alignment of it's about alignment of the data with the business problem. That's, to me, is one of the key things in data science. Is it's aligning what is the business problem, so identifying that, and then aligning the data. Now that may be a motherhood statement, but very, very, very few. There are very few organizations that do that well, because it's not easy, because you have all this data out there, and we live in a big data world, yet we have this problem. So how do we align that data with the right business problem? And the second thing is measurement. So if I build something, how do I measure that it worked? Right? How do I measure that it worked or that it performed? And then the third thing is dollars. Can I prove that what I did delivered incremental value or incremental ROI? So there's some questions here. I'll ask you guys. What do you think is the biggest need in the marketplace right now? So in data science, so when I say the biggest need, if you were hiring or if you were starting, do you think you need tools? Do you think you need data? Or do you think you need people?
You need people and proper questions.
Yeah, you need the right. It's again a motherhood type question, but you need. To me, the data's out there and the tools are out there. So the biggest need, if I'm building a competency in data science, is having the right people. Mm-hmm. So having people that are inquisitive, that are detailed with the data, so they don't just go blasting away, that they check. Because when I started 30 years ago, or whatever it was in the late 80s, and I was learning how to program, I didn't come from a programming background, but I always checked my program against the data. Mm-hmm. So what was it doing to the data? And it took time, right? It was very time consuming. And I didn't come from not like you guys. I didn't take any computer science courses, but I had to check, make sure that what I was doing with the data was right, given the program. So there was a lot of, I would spend a lot of time making sure that if I was sorting a file and joining and merging, that what I was getting was right. And as opposed to, and so I would check records one by one. So it's that level. That's why I'm saying it's alignment of data with the right business problem. Yeah.
Very interesting. I think we all have questions. I also have at least two questions.
I'm enjoying.
Yeah.
Okay. Please, the question I have is, I understand you just said that it's having the right people that you think it's the most important.
Yeah.
Would you go for the right people first, or would you look at, first of all, identifying the need, the problem in the marketplace? So in terms of, when you look at what the consumers are looking for, and then use that, since you identify the problem, and use that to kind of look for the right people. Is that how you go about it? Yeah,
maybe I didn't address that properly. When I talk about when I talk about the need in the marketplace, I'm talking about building up a data science competency. Right?
Yes. Okay.
So data science competency means you're going to have many different business problems. Many. And you might, but what I need, and I might need more, I might need specialists, but number one, I'm going to have many different problems, right? And I might have data all over the place. So what I want is a person that's very nimble, very flexible, that can go from, that can say, here's the problem. And by the way, you know what? We don't need to go to social media and pull off all the commentary. We have some data here. We have some call data here, some complaints. If I'm thinking of a telco, right? Mm-hmm. We have some good data here that can help us build a good churn model, as opposed to going out to social media, which may be biased. Mobile data. Like if we were doing some stuff with a restaurant or whatever, what could we do with mobile data to build a solution? Presuming that we circumvent the privacy law. So it's getting that person to think about the data, to think about being able to think about different business problems, and being able to work with the data. But the person has to have the discipline. The person has to like thinking through the many different business problems that are out there and being intrigued by that. But the person also have has to have that discipline of going through the data and saying, okay, is the data lining up? What data do I need? And going through the process. And I'll walk you through some things that we do at the front end to try and make sure that the data is good. So it's so that's why I emphasize if I'm building, if I was back on my own, which I'm thinking about, I was back on my own, as myself, but I would be looking at, for sure, if I'm going to hire somebody to work with me, the person needs to be technical, for sure. But that's a given. That's a given. That the person, and even if the person doesn't know, like all the tools, they'll learn it, right? Because they'll spend the time and they're keen. But they have to have, and there's a lot of very good tools out there. They have to have that understanding of working the data and aligning it to solve the business problem. That's why people, to me, getting the right person is to me the key.
So you want to look at, I'm so sorry, Kieran.
I know, I'm answering a lot of questions. Go ahead.
His response is triggering the second question I already had initially. So would you it would be like building a data science team, from what I gathered from you, because I don't know so much, but in reality it seems like for data scientists maybe they'll be more technical than businesses. So would you look into like having someone who is technical but also open to understanding business and someone who understands the business problems? So if they work together, then they are aligned to solve.
That would be, if I'm building a data science team, I'm looking for the latter. So I need somebody that's technical, but that doesn't necessarily need to be the programmer that wrote the algorithm for Google for artificial intelligence. I don't need that type of person. And that type of person, to be quite frank, probably doesn't have that breadth of understanding of business. Like, they're very, very technical, and they like being immersed in programming and working through like all the different math that's out there for artificial intelligence. They're not, I shouldn't say that, I'm being maybe being generic, but most of those people are very interested in the arcane stuff of like improving that algorithm and the next best thing. So Google and Facebook, when they're hiring a lot of data scientists, are they're going to have much deeper knowledge in terms of building algorithms and really programming. Like you guys all know, when we use SAS, we're not, people say, Richard's they don't know, Richard's building a model, he's coding, Like, I'm not coding logistic regression. It's a procedure that I use, right? It's a procedure that we call in SAS. Same thing in R or Python, right? You're calling a module, right? But it's the whole process of working the data, right? It's this whole process of working that, and that's what we need to understand, right? So those of us that have been at it, we get that, right? There's a process that we adhere to, and you can use whatever program you like. All of us here are biased towards SAS because that's what we've grown up with, right?
Yeah. I will ask one question, and I will.
Can I answer your question?
Yes, perfectly.
I will ask one question, then I will keep my enthusiasm till the end. Say, for example, there is a person who doesn't know statistics.
Right.
So he doesn't have that knowledge of statistics.
Yeah.
How people like those people are me. How people like me can build that knowledge. I'm not saying I just wanted to become a super data scientist or something, but say, for example, we have a problem, I got the data in, I did the basic analysis using SAS and SQL, throw out some numbers saying that we are doing good here, good there. But my thinking cannot go about that because I don't have that statistical knowledge to extrapolate to that point.
Right.
How can I build that?
Well, I would say if you're going to go into that field, you need to have that statistical training. So like you need to understand like what a correlation does, factor analysis, the difference between logistic regression, deep learning. What is deep learning doing? Well, do I like today just even on the Metro, like I'm reading something about deep learning and there's like tons of equations. And when I had coffee with somebody on Monday who wants a career in data science. Like when I'm reading this stuff, do I understand I try and read, when I read these things, I'm trying to look for that nugget and saying, okay, what does this mean from a business standpoint? So when I look through all, so I go through a lot of I do read a lot of academic papers, and I might understand maybe 15 or 20% of it, but I'm looking at it to try and get that nugget that says, what does this mean from a business standpoint? So the reason I'm saying that is you need to have an understanding of statistics in terms of distributions, the concept of standard deviations, variance, some of the more advanced types of techniques and why they're different. So, if I'm doing, if I'm using, when would I use a factor analysis versus clustering? Why would I use a logistic regression versus a multiple regression? When would I use deep learning? So you need to have that basic level of understanding, like outliers, like how you deal with outliers. And that. These are pretty basic, but I would argue that a good data science course, an advanced data science course would be good. But you need to have that basic level of statistical knowledge if you're going to be a data scientist.
So the one thing I get
probably in today's world, I'm a bit of, because I've been at it for 30 years, I'm a bit of a cowboy. So when I came at it, there was nobody. So I applied for my job. I worked at Reader's Digest. The job was, it was in Montreal, right? So I did my MBA. Remember we talked? I did my MBA at Concordia.
Okay.
So, I was like in my 20s, and I'm going, okay, I need a job here. And I did my research paper. My research paper was on the bond rating industry, right? And I was trying to determine that the different bond rating agencies were inconsistent in applying their rating. So again, I was using data mining. At that time, I had to collect all my own data. And when I say collect, there's nothing on the internet. I had to go in and enter in key in my own data from the books. So I went into 200 companies. I got an A+ because of all the work I had to do back then, because it was all manual, right? But I remember I went into the library down at Sir George. This is before the John Molson School of Business was an empty parking lot back then. So I went in and did. I ran a factor analysis and I did discriminant analysis as techniques. So that's what I applied. So that's how I got hired at the Digest. Was doing that, and so I was, because they were looking for a master's in mathematics or a master's in statistics. I didn't have that, but I used these techniques, and I wrote that in my covering letter, and then they hired me because they had seen that I had actually practically applied these techniques, right? So from there, but my MBA was, I did do my major was quants. So, but it's, you talk to a lot of people that are in departments, directors or VPs, a lot of them, have, they're coming with much more high-powered math degrees than I did. But, back in those days, it was, it was open territory, and I just, there were business problems, and what I did is, and I used my skills to the best of my ability to solve that business problem, right? And SAS was very good because SAS was always a resource in terms of like the statistics and using the right statistics. They were a very, very good partner. I had access to all the techniques, and then I would read like the SAS manuals to say, okay, what does the output mean, right? So SAS that's why I'm a big lover of SAS, because I was able to enhance my learning in terms of what the output meant, the differences, and so my stat knowledge improved by virtue of using SAS over the years and all the different procedures. And if I had really more math questions, 919-677-8008. That was the SAS hotline. That's I used to call them up.
I see.
That's how I learned.
That's great.
Yeah.
Okay. No more questions?
I will keep my enthusiasm.
I have at least 3 questions. I don't know if you want. I can ask them right now.
Sure. I mean, we don't have to. Yeah.
No, okay.
Whether we
one of them is related to like this slide, because more and more we are like people are talking about data and data sciences, but I'm still wondering if to be data scientist you need like a statistical skill. I mean, data scientist is statistician. Who is data scientist? if I ask you to define, that's my first question.
Yeah, yeah.
And you want me to ask all of my questions?
Well, let me ask the first one. So
Okay.
the data scientist is to me, is a mix of different skills.
Okay.
So it's a mix. It's somebody who has statistical training. Do they need to be a PhD? No. But they have to have a statistical, have to have strong math and stats knowledge. They do. Okay. So, you know, back at EA where I'm currently working right now, you know, I've known the guy. This guy who's Tony Lee, who's the chief methodology geographer. He's got a PhD. I mean, his level of math is far superior to mine. So I'm not going to challenge him, like in terms of the math or the academic stuff. But I come at it from a different area. Like I've applied my skills across so many different areas, right? That, you know, I bring different things to the plate that an employer is going to find attractive because I've applied. But I try and leverage whatever knowledge they have, if it makes sense. So I have a strong body of math and stats knowledge. That's one thing. The other is, if you're going to be working the data. So what I mean by working the data, it could be programming, or using tools that allow you, and I'll talk about that later, about going through the process where you're working through the data. So those are the two things: is stats, and then being able to work the data. And I guess the third is being able to align that with the business problem. So I do believe the role of the data scientist, especially as tools become more and more automated, is you're going to find a lot of these data scientists. You'll find that there's going to be a bunch of data scientists that may even have less technical skills because they have a lot of these good tools that are getting better and better. But they need to be able to still work the data. So whether I'm working internally or if I'm working on behalf of clients and they ask me to build a model or create a report, and they just have this raw data, I need to be able to pull that together, right? And so I need tools. But the process stays the same. So that question is you need problem solvers, you need stats, and you need the ability to, I call it not programming, used to be programming, but working the data to create that analytical file. So hence the word data science.
And my second question is related to data manipulation. We have I don't know if I can call that the Pareto principle.
Yeah.
But more and more people are saying, for example, for data manipulation, we are taking around 80% doing data manipulation, and statistical analysis is around 20%.
Yeah.
But some people start to say this percentage is not correct. I don't know what is your point of view about that.
Well, what the people that say it's not correct, what are they saying it is?
It's much more balanced, meaning, for example, data manipulation can take 80%, is less than 80,
right? They're saying
maybe around 60, and statistical analysis, model building, and things like that, and report writing can take more than 30%. I don't know. What do you think about that?
Well, the report
experience.
My experience. I mean, the tools are getting better, but it's still, if you're doing it quicker, it just means it's less time. But it's still a task that might have taken me 6 weeks. Maybe it takes me 2 weeks now. Whatever. If I'm building a model, it's still most of the work is still the data manipulation. I would say it's probably 80% plus, maybe 85, because there are procedures out there. Like if I'm using deep learning, right? There's procedures out there to take advantage of that. But it's how I'm working the data, right? To do that. And so I think, I still think it's 80-20. Will that change over time? I don't know. As if we get more and more automated in terms of creating an analytical file. So if you have one file that can be used for multiple problems, because you could get to that point where you have a data file and it can be used to solve multiple problems. Then you're trying to spend more time trying to move that needle mathematically. Then I could see it, because then you can say, okay, you can start playing with, maybe if it's really big data, you can start playing with neural net models, right? So I can start, maybe I'll start playing with the levels by changing the nodes, changing the number of hidden layers, trying different optimization type of algorithms. So you could do that, and that's where you're starting to play with the statistics in that. But that is one part of it. Then again, as you say, you got to do the report. You got to write it up. Like, what is this? Okay, I built the solution. What does that look like, right? So it could change. I mean, right now, historically, most of us are still saying it's like about 80%. It's about 80% data manipulation. Like, we're not there in that perfect environment. But I think once you create that analytical file, and then if you have multiple problems that can be solved off that same file, then I think it can become more. Then it becomes more 50-50.
My last one, because we need to leave at 11.
Oh, okay.
We have another meeting here, so you tell me. From my experience, one of the biggest challenge from my experience was, for example, the deadline. Usually when people ask you to do some task, they would like to have the result right now.
Right.
And most of the time you need to take like at least 1 week work or two week work. I don't know from your experience how you manage this kind of like deadline pressure.
It depends. Well, it is based on experience, but depending on the problem.
Yeah.
Like if I'm building a model, if I'm building a churn model, and it depends on the complexity of the client. So if I'm building a churn model for, let's say a retailer, right, that has maybe a couple of files, it might take me 3 weeks to build the model if the data is pretty contained, but there's a process that we have to go through because I have to understand the data, right?
Correct.
So typically we need 1 to 2 weeks just to go through all the data and make sure it looks good. Which is that I haven't talked about that, but that's we call that the data audit process. And you have to go through that data audit process. So that's minimum 2 weeks just to say, okay, does the data look right? And then you're going back either to the client or internally if you're working with a company. You're going back to that business stakeholder and say, okay, this is what we're finding with the data. Does this make sense? Because then you're going to the next step to create that analytical file, to create that file that you're going to use to, whether it's building a model or it could be to produce a report in Tableau, like you need to create that analytical file, right? And so that's how we manage it. But we go back to the client and we list. So we'll list the different things that need to be done, and they can say, okay, well it's too slow. Okay, go to somebody else. Good luck. Go to that 28-year-old and get him to do it. As we say in French, bonjour la visite.
Okay, that's good to know.
Yeah.
Because most of the time what I see is like people who like to have the output right now, and they try to do that like as fast as they can, but after you realize you miss like a lot of things, and you have to do everything.
Yeah. You have to educate them. Like
you're
absolutely. You have to educate them. And if they're going to push back on you, you need to say, "Hey, you know what? I've been at this too long. Go to somebody else." It's better on your reputation to say, "Go to somebody else."
Yes, and because when you try to do that and things is not done correctly, it's like your reputation.
It's your like. I mean, one thing is I've worked with a lot of, and I've made mistakes. We've all made mistakes, but I've always worked to correct them, and I've worked with clients because at the end of the day, you have to care about the person that you're working with. Yeah, like forget data science. Like just as human beings, you have to care about the person you're working with. They're hiring you, and you have to care that what you're doing is of value, right? So if they're going to push on you, hey, go somewhere else. Go to that person, right? Like this is what I do. And I'm going to work closely with you, and then people trust you, and they respect you. They know you work hard. They know if they want to see something, because you present something and they're going, that doesn't look funny, that doesn't look right, Richard. Can you go back and check? Yeah, I'll go back and check. I'll go back and check. just to make sure, or maybe they don't like that variable that's in there because they don't understand it, so I'll go back and try something else. So you're always like doing what's best, but not compromising. So I will do things that are suggested by the client because they may not be comfortable, and as long as the solution doesn't erode, I'll do that. But not at the point of compromising something, right? Yeah.
Thank you.
So here, I'll go, I know we only have a few minutes.
Yeah.
So this is kind of like a data discovery process, which kind of gets to a lot of what I'm talking about here. So here, we use this process where a lot of clients come in and say, we have this data, and we don't know where to start or what we should do. So it's very much an open-ended discovery process where we're trying to develop what we call a data-driven strategy. And so we have this 4-step process, right? So we have preparation, which means meeting with all the different people. I'm going to go through it very quickly. The next is the data discovery, this is the data audit, which I'll show you some examples of that. Then we have preliminary analysis, where we actually start doing some analysis. So the second point, we've actually created the analytical file. The third point, we start to do some analysis. So we may do some value segmentation. Who are our most valuable customers? What do they look like? And then building the roadmap. So here, these 3 steps start to lead to the last point, where we're actually outlining to the client what we should be doing. So here's the roadmap. Here's the vision, right? So this is when we've done this, for when I was with Boire, before I sold my company, we did this a lot for various organizations. And I think a lot of software companies and a lot of companies, I should have IP'd this way back when, I never did, because I'm not a rich man. But a lot of software companies have embedded this, right? And you'll see this a lot in the literature. This is something that our guys have been doing for 15 years, 20 years. We've been doing this type of process. This is the what I call the standard data science process for a project. So it's not a data discovery. This is like a data discovery that could be within this process. But this is basically, what's the problem? Okay, what is the problem? It could be a model. It could be segmentation. It could be data, developing. It could be an open-ended data discovery. But step 1 is that problem. Step 2 is the information. How do I create the information to create an analytical file? Step 3 is what are the tools that we should use, right? Which could be models, statistics, and then 4, deploy. And more importantly, I talk about measure, being able to measure and track, right? So here I wanted to talk about, as part of the data science process, because I talk about creating an analytical environment, part of that, so part of 2 is what we undertake is called a data audit. So this is the first thing we do when we get data from a client. You've all heard of feature engineering, that fancy word, which is basically creating variables. So this begins with the data audit. So what does this mean? Basically, it's our initial glimpse of the data. We take a 3-step process. We'll look at a random sample of records. We do frequency distributions and then metadata reports. So I'll show you some examples of that. This is an example. This is an example of some transaction records. Basically, you have 4 fields. So I'm just taking a look at it, right? Just to make sure that everything is lined up. And you can see here, I sort of make this up, but you can see here, down here, this looks odd, right?
Yes.
So you go back in and you go back to the client, go back to the stakeholder. You'd have to find out what's going on there, right? So we will put, and this could also be a check on the fact that we've imported the data incorrectly. We're not reading it right. So this is kind of and I have some other examples which I didn't bring in. But these are things that this is basically your first check. The second one are frequency distributions. So I'm just using 3. We will use, if we have 10 files and 20 fields on each file, we'll do 200 frequency distributions on each. And some of them will be categorical, some of them will be continuous. And if it's categorical, there may be a lot of, I don't know how many you're familiar with cardinality. With categorical, you may have a lot of, the cardinality means you have a ton of different outcomes, right? So we have routines, or my guys have built routines where we just take a look at the top, the most frequently populated ones, right? And again, I just wanted to illustrate that this is, these are the types of reports we get. And then the last one, which is a really cool one, and I'm only showing some of the data here. This is, again, we do this on each file that we get. So we have the variable name, column type, so the type of format, whether it's character, numeric, date. Number of unique values, so it gets into cardinality. Less of an issue with continuous, like numeric variables, but with character, you need to address it. Like for instance, like postal code. Postal code, like you have a lot of cardinality where it's a character field, and you have few records. So you need to understand that when you're creating variables, because I'm not going to create a postal code variable.
Yes.
Too small, too sparse. Gets into sparsity, right? And then the same thing with missing values. So again, data scientists are always looking at missing values. Right? If there's a large percentage of missing values, it's not going to be useful. And then we have the percent missing and non-missing. What you're not seeing here, which I haven't included because I couldn't fit it on the slide, is we'll look at for numeric or continuous variables. We'll look at the min, max, standard deviations, means, whatever.
Yeah.
So we have to get.
So the frequency procedure you're talking about, right? At that stage, would your team look at outliers?
Yeah.
That's before this stage, right?
Yeah. We would. Well, you would see that. Yeah, you would see that by the min max. You would see. I mean, it's only looking at the one record, so you would get a little glimpse of that by.
So you don't have to do proc univariates to.
Yeah. Yeah, you would do proc univariate. I mean, what my guys have done this in SQL. Like I used to do this. I did this in SAS initially. So the guys, because I'm going back 15 years ago. This is what I did this in SAS, right? Mm-hmm. Then what they did is they prettied it up. They said, They said, Richard, let's take your code and we'll put it into SQL. So they took my logic, or the logic that we built in SAS, and they took, so I built it initially. Then I had another SAS programmer who was even better at SAS than I was. A really, really good SAS programmer. He macrotized everything that we did. Mm-hmm. So they took his programs, not mine. They took his programs and then they built it into SQL, so that it was much more structured, much more structured. And so they were canned. What they were able to do was operationalize these. So every time we have new files, basically it's push button. Just call it. It calls the routine and it executes these reports. So they're automatic, right? And So we have like mins, maxes. Mm-hmm. So a lot of other rudimentary statistics, which you can see are columns, which I've not included here. But that what it's doing is it's giving you insight into the particular variable, right? So I know. And I could take a look at the mean. I could take a look at the mean. What I will take a look at, I don't even need to visualize it. Although you could do a graph, but I can tell the degree of outlierness by taking a look at the mean and the standard deviation.
Yes.
I don't even need to look at the data. I can just take a look at the mean and the standard deviation, and I know it's huge. I have huge outliers, right? And stuff like that. So that's always been my rule. But we have routines. I didn't tell you this. We also have routines that we built that normalize the data. So for outliers, we've actually, for continuous data, we built routines that standardize it. Mm-hmm. So for instance, if we take a look at, let's say, spending, right? You may have that guy that spends $1 million, but the mean is, let's say, the mean might be let's say $1 million. I'm being silly. Let's say that you might have this guy that spends $10,000, but the average spend is $100. So we need routines. We built routines where we sort the data, and we go in and we cap it. So we actually cap the data through again SAS macro routines that my guy built, which I have all his programs here, and it goes in and it caps the data. So basically what we do is we sort the data. So we'll sort a data like spending into 100 centiles, top to bottom. We'll go to the top centile, calculate the mean for the top centile, and then do plus 2 standard deviations from that top centile. And then that value becomes the cap. And we do that for every variable. That's continuous, so it's automatic. So
interesting.
Yeah, so we've that's what we've done. Now, here just again, just some more talk about. There's a lot of buzz about machine learning, right? Everybody's talking about machine learning. You go to these conferences or these innovation talks down there. Everybody's talking about machine learning. Marketers are talking about, yeah, we'll use machine learning. They don't even know what it means.
Yeah.
Machine learning is basically there's different levels of machine learning. To me, I was using machine learning my first model that I built at Analytics. The reason I say that is because I had data. I put the data into a proc, and then the procedure, the machine, gave me back the output, not me, the machine. And it was, you could take a look, it was a stepwise regression. As long as the tool's interactive, I mean, I don't call doing, heavy addition and subtraction machine learning, where you're just kind of inputting and it's adding up a bunch of row of numbers. But machine learning is where there's interaction going back and forth, which is stepwise regression. Anything that's doing some sort of interactive math, albeit even very simple if it's linear, or if it's signaling, that's machine learning, because the machine's doing it. I'm not doing it. The machine is doing that. So that, and then you have decision trees, which is more, which tend to be more nonlinear, and then you have the more advanced, which is the deep learning, right? Which is neural nets, right? So there's different levels of machine learning, but to me, all these are forms of machine learning, because the mathematics is back and forth, right? Is interactive, right? So it's, to apply, whether using, when I would run a regression, I would run, to get my best variables, I would run a stepwise, and I would use both forward and backward as my options. And then what it would do is it would run through the routines, and then it would select the best one, then look at the remainder, and then keep that one if it was relevant or not. But it would basically do it, trying to optimize that linear function. So what's this? So I've talked a little bit about machine learning, but at the end of the day, the business people don't really give a crap about this. Right? They don't really give a crap. They may all say, oh yeah, machine learning, because everybody's hyping about it, so they're all excited about it. But you go back to the office, you got to deliver dollars, right? So this is really kind of a visualization. I don't think I've included the actual gains table or decile table, but I want to just illustrate. Here is a solution. So I've built, this is a simple response model that I've built, and I've taken that response model and I've applied it against a holdout group, against a validation sample. Right? So it's different. I have a sample names here, I build the model, and then I take that model and I apply it against a holdout or validation sample. So that validation sample has been untouched by any modeling algorithm that I built. And what I do is I take that, so all these names have been scored with whatever machine learning tool that I'm using. And I rank them. I rank that holdout or validation sample into 10 groups. So this is my top scored names, and these are my bottom scored names, like decile 10. And you'll notice on the y-axis, this is actual observed. So this is actually what would have happened had I applied that model to these names. So you can see here that I've got a pretty good model in terms of rank ordering, right? Versus if I had a lousy model, then it's flat. Right? I'm not getting any differentiation. So if you remember when I was talking about what we as data scientists are doing, I'm more interested in my world. If you talk to Andrew Ng, he'll tell you it's all about accuracy. Is my observed, and is my accuracy rate between what I predicted and what's actually happening close, right? This kind of gets at that in terms of the ranking, but I don't care. Neither does the business. Business people don't care that, oh, your accuracy rate is really good. Who cares? What they want to know is ranking, because I can take these deciles, so what you're not seeing, I can convert them, I can do a spreadsheet exercise where I can tell you what's the return on investment based on the marketing costs, based on how much revenue that person's bringing in. I can take the mechanics of this and build ROI into that, right? So that's my world in terms of consumer behavior and what consumers are bringing in. So I'm less about looking at the classification, the accuracy rate, although you know, if the model, if you have a very, very good accuracy rate, or if your error rate is very low, what should happen? I should really, in theory, get an even steeper curve. So even better ROI.
So if I understand well, all of this side is like a model. You have different models, let's say regression or...
It could be, it could be a regression model.
Okay.
It could be a decision tree.
Okay.
It could be a neural net model. So it could be any model.
Okay.
What I've done is I've taken the model
Okay.
and I've applied it to a different group where I had observed behavior. And I'm saying, how do I use this model against this holdout group? What would have been the results?
Okay.
And so this is where what you're seeing here is the results. This is the response rate is 5%. These are the names that I predict to be the highest responses. This is what I'm predicting to be the best names.
Mm-hmm.
And they're actually coming in at 5%. This is what I'm predicting to be the worst names. Right? This is what I'm predicting. And it's coming in at 0.02. If I had a lousy model, then it's flat. It doesn't like it's like I might as well throw a dart, right? Because here my response rates. I mean, I just put a straight line, but typically you'd be very weighted, right? There's no ranking if you have a lousy model. So when we're evaluating, why I love what I do. I've been at this for 30 years. Why I love what I do, and you can tell what's his name. The other guy, Roger, likes what he does. I don't know what that's. He's in a different area. But what I like about what I do is that you always have a report card. Right? You can always see the results of what you're doing. And you can apply different models. At the end of the day, if I have a data scientist coming to me, or Andrew Wing, or whatever, any of those guys, can you beat that curve? Can you beat? If you can't, then I'm going to see a steeper curve. That's in my world. Not, as I said, I don't have experience doing images or text recognition, NLP, based on what I've read. I understand the mechanics and the data science in behind it, so I understand what's been done, but that's not the world that I've lived and breathed in for the last 30 years. It's been on consumer behavior, right? How consumers, react to marketing offers, risk, like how risky they are. That's where I've played it for the last. So I wanted to show you, these are some of the other tools that are now being used. So those of us that are SAS programmers, where we have to kind of go in and code, now there's tools, and I'll mention, this is Alteryx, which you may be familiar with. Alteryx, Alteryx.
It goes well with the Tableau, right? So
yes, well you take the output of this,
and put it in
here, and you put that into Tableau. But what this does is this takes, like, if you think of like in SAS where you have proc import, or data input, data info, whatever, you have here, you go into Alteryx and there's a module that says load data. And it's drag and drop. So you guys are familiar, like EM, Enterprise Miner, right? Kind of like that. Except it's not as expensive. Very much cheaper. So these guys have gone in and they created, I should have worked with these guys 15 years ago, because I don't know, they took a lot of the stuff that we did, even like the data audit, they've embedded the data audit routines into their software as well.
Wow.
Yeah, it's not as automated as ours is, but you can do some of the data audit stuff, like checking the data. Because one of our guys said, Rich, he said, look at this, and you can go in, you can actually check.
What problem?
So what this is doing is it loads data in, you can inspect it, you can sort and join, create variables. You can create variables, derive math. Like do mins, maxes, means. So you can do a lot of different things with the data. Look at total sales. So from here, like, again, it's a process, right?
Yeah.
Very similar to what you see, like maybe with EG or EM, and then you have the output here, which is basically a file that somebody could read into Tableau. Right?
Yeah.
So this is one. Like and there are other players. Like they're not the only one. Like there's another company called Sisense, which is a competitor. So as I said, like the world, like the software tools are exploding. It's a very tough business to be in
Adobe
today.
Analytics, I hear about.
Yeah, I think the business to be in is to be more. You're never going to be rich. More of a kind of in the consulting, like tell people what to do, like how to do that, right? So if you could IP that, make software off that, then I'd be rich. But here, this is this is just an example of one what I call a tool to create that analytical file. Remember I talked about the analytical file?
Yes.
Yeah.
This is a tool. This is
analytical
without coding. Remember, because the presentation was without coding,
Yes.
right?
But without coding, it always feels like you are restricted to what the business rules already fixed.
You're right. You're right. So there may be things that you want to do here, like if I had a string file, right, and I want to do some tricky coding, or to create maybe some arrays or whatever, certain variables based on sort of transposing the data.
Yeah.
There may be things here that you can't do, that you're restricted. So, I mean, the programming ability is always going to allow you to do anything. These tools, there's always going to be that restriction, right, that you can't quite do. SAS, you guys are familiar with this. This is more on now you have the analytical file. So now you can start to look at different models. You guys are familiar with factory modeling. I mean, like that's a product that SAS offers. You have all the different. SAS has tried to, has stayed up to date with the big data. So you have call-ins if you're playing in a big data environment. And a lot of the big companies are. They'll have call-ins to a dupe, which is almost like it's like, as he was saying, like it's a call-in where you can use SAS to process the data in a parallel environment. The way I would do it is I would be calling, if I was working, let's say for Rogers, I'd be calling them and say, okay, give me the code. Presumably we have the hardware to all the data so that I can run and get what I need. And then once I get what I need, I'm back to my steps, right? Yes. Back to my wheelhouse, right? Where so that's where you always want to get back to your wheelhouse, right? Where you've got the data. Right? And then this is another one, Data Robot, which is another automated routine. So where you can again, very, very much like the factory type of approach to modeling, where you can look at multiple models at the same time, so very quick. So the world is moving a lot towards model automation, where you can put in an analytical file. I still think there is the need. There is, as we get more automated, there is the need for that person, the data scientist, to check.
Yeah.
You can't. If you are going to be. You're going to be. You don't want to be. But you're going to be up the creek, as we say in English, if you just rely on the tool without anybody checking results and anybody vetting it. So you need to have knowledgeable people using this tool. And then the last slide is this. This just talks about the future of the data scientist. You had asked me that question, right? So where do I think the future is? Mm-hmm. It's sort of left brain, right brain. This is one of my favorite slides, because I think this is where it's going. Is you need this person that has this understanding of the math and linear, and then this side is kind of the touchy-feely, but that business, that intuitive.
The EQ and the IQ.
The intuitive. So, like, you have to have that inquisitiveness. Like, I read data mining books, but I also read a lot of history. Yeah. It's a passion. It's a passion of mine, right? Like, I love history. You can say, well, that's, because it's more about, it's looking, but it's also looking about a lot of subjectivity and stuff like that, about how facts can be used to solve future problems, but understanding the history of it.
Predict or influence our problems.
What I have this question always bothers me. It is always difficult to have a depth and breadth. What I have seen is whenever you have depth, mostly you lack breadth, because it is quite impossible for a human being to have all round of things. You have a weaker of one thing and stronger at other thing. So I always, whenever they say data science, he knows all and all that always sounds very, unrealistic to me, because to develop a depth in one certain thing, it takes years and years.
Yeah. I mean, it's, you're not going to, typically when somebody comes in as a data scientist, you're typically going to be more on this side, right? Where you're coming in. If you're going to come in, somebody who's starting off their career, they're going to be coming in here. But as they progress,
You
as
have
they
to be
progress,
open to the
they
other
should
side.
go more towards the right side, right?
Yeah.
So, like when I was starting out, you know, a good piece of advice that somebody gave me was like, they said, if you have an opportunity, go tech. Become more technical in what you're doing. Learn as much as you can and get technical. Because you can always, it's much easier going, for those of us that are, much easier going this way than this way. Because I can tell you, there are a lot of people here, but if they want to become data scientists and they've gone here, good luck. It's very, very difficult to go from here to there. Much easier for us guys. We just have to work, but you have to have the appreciation. I just find it's much easier going left to right.